We are going to do a couple examples of solving exponential equations that do not have common bases. So if we look at example 1, we have the equation 5 to the power of 2x equals 812. Now, 812 is not a power of 5, so we can't cancel our bases like we've done in previous examples. Instead, we need to convert to logarithmic form. So our base and then our exponent, this is our product, not our exponent, and our exponent. So if we remember the formula for converting to logarithms, it says the log base 5 of our product, 812, is equal to our exponent, which in this case is 2x. So to solve this for x, we just divide everything by 2. So x equals log base 5 of 812, all divided by 2. Now, before you rush to your calculator to plug this in, you don't have to. This is our answer. This is what we call an exact answer. It's exact because if we plug this into a calculator, it's going to give us a decimal with an infinite number of decimal places. And in order to write that down, we have to round at some point. Even if we round at the 100th decimal place, the moment we round a number, it's no longer exact. So this is the exact answer. Log base 5 of 812 divided by 2. And so if we're just solving an equation, we're going to leave our answers in this exact form. If this were an application, however, we want to approximate our answer by finding a decimal number. But since it's just a question asking us to solve an equation, we don't have to worry about it. So let's turn to our next example. Solving the equation 4 times e to the power of x plus 1 equals 36. Now you might want to rush ahead and convert it to log form right away, but we can't because this 2, that's a 4, that 4 has to be taken care of. And we can do that just by dividing both sides by 4. So on the left side, we're going to have e power of x plus 1. And on the right side, 36 divided by 4 is 9. Now we can put it into exponential form. And if you remember, when we go from exponential form to logarithmic form, base e, we're going to have a natural logarithm, ln. So we have the natural log of 9 is equal to x plus 1. So to solve for x, we just we subtract both sides the number 1. So we have x is equal to the natural log of 9 minus 1. And as before, this is our exact answer. We can plug it into our calculator to get an approximate answer, but since we're just solving an equation, leaving it in the exact form is perfectly acceptable. And this has been solving exponential equations by converting them into logarithmic